A quiet disappointment settles over American roads in the early 1980s. For the first time in decades, the country that once lived on horsepower is unsure of what performance even means anymore. Gas prices jump without warning. Emissions rules tighten. Compression ratios fall. Engines lose their voice. Horsepower numbers feel embarrassing compared to the glory years. The V8, once untouchable, starts sounding tired. But something else begins to rise in that silence. A sharper sound, a new kind of breath, a turbocharger spinning itself awake. This is the moment when American automakers try a different rescue strategy. If big engines can't survive the new rules, maybe smaller engines, boosted engines, can bring performance back. On paper, it sounds almost too perfect. Force more air into an engine, burn fuel more efficiently, and get the power everyone misses without breaking fuel economy laws. But behind the scenes, it's not that simple. Teams of engineers work late nights, surrounded by drafting tables, paper diagrams, and early computer equipment that feels like it's held together by hope. They chase detonation problems. They fight heat. They try to convince older managers that turbocharging isn't a gamble. It's a lifeline. And yet, every small breakthrough gives them a reason to keep going. Buick takes one of the boldest leaps. Their engineers look at a 3.8-liter V6 meant for basic sedans and wonder, almost quietly, can this thing become something more? Early test runs are rough. The engine knocks, bearings complain, temperatures climb. But once the turbo starts breathing properly, something unexpected happens. The torque curve looks like a small block waking up. Ford goes in a different direction. The SVO team believes performance doesn't need to come from brute force. They want precision, balance, a Mustang that feels sharp, controlled, and European in its behavior. But they know the risk. A Mustang without a V8? For many drivers, that's unthinkable. The hesitation is real. Chrysler moves with another kind of confidence. With Carroll Shelby joining them, ordinary K-platform cars start hiding engines that don't feel ordinary at all. Light chassis, strong boost, and handling that catches people off guard. They're not perfect, but they're alive in a way people don't expect. Even Pontiac experiments with a turbocharged Trans Am, a boosted V8. Heat management becomes a daily battle. Packaging is tight. But the engineers push through it because they know, deep down, they're building something ahead of its time. All these machines share one belief. Turbocharging might save American performance from disappearing. It might keep speed alive. It might satisfy rules, buyers, and tradition at the same time. But convincing people is another battle. Many drivers don't trust small engines. They don't trust boost lag. They don't trust a sound that isn't deep and familiar. And early turbo problems, even small ones, make buyers step back. Still, the truth is simple. American performance doesn't die in the 1980s. It transforms. Turbocharging tries to carry it into a future no one is ready for yet. A future where power doesn't come from size, but from pressure, precision, and imagination. The story of 1980s turbo cars doesn't begin with technology. It begins with loss. A slow, steady decline that reshapes American performance from the ground up. By the mid-1970s, the country is caught in a cycle it never expected. Fuel shortages, long lines at gas stations, economic pressure, and an automotive landscape that feels confused. Drivers who grew up around big displacement V8 power suddenly watch those engines struggle under new rules. Emissions equipment chokes airflow, compression ratios drop to survive low-octane fuel, horsepower sinks to levels that feel almost unreal for anyone who remembers the 1960s. You can almost feel the disappointment in old brochures and road tests. Cars that once made 350 horsepower now barely make 150. Some don't even cross 120. And this isn't just engineering, it's cultural. Performance is part of America's identity. Weekend drag racing, boulevard cruising, muscle car pride. When engines weaken, something in the national automotive spirit weakens too. By 1979, the second fuel crisis hits. Gasoline prices spike again. Lines stretch longer. Drivers begin to accept that the old world of performance simply isn't coming back. Car magazines start calling the muscle car a relic. Manufacturers shrink engines for fuel economy. Insurance companies raise premiums on anything remotely powerful. Buyers retreat into safer, quieter, more efficient cars. Performance feels finished, like a closed chapter. But deep inside the engineering offices of GM, Ford, and Chrysler, a different thought begins to take shape. A question. A what if? What if you could get power in a new way? Not from size, but from pressure. What if air, compressed, controlled, and delivered with precision, could give small engines the strength they lack? Turbocharging already exists in Europe. Those cars aren't perfect, but they prove something important. Boost can replace displacement if you treat it with respect. American engineers watch closely. They see potential. They see a path forward, not to copy Europe, but to use turbocharging in an American way. More torque, more durability, more real-world power, a new form of muscle. But the challenge is huge. The United States has larger highways, heavier cars, hotter climates, and lower fuel quality. Turbocharging isn't just a bolt-on idea here. It needs reliability, cooling solutions, stronger materials, and smarter timing control. Engineers know all this, and yet, they push anyway. You begin to see a shift around 1980. Automakers recognize that they can't keep shrinking engines without losing the last of their performance customers. Something must change. Something must evolve. And turbocharging becomes that evolution. Fuel economy laws are strict. Manufacturers need better mileage numbers without sacrificing drivability. A turbocharged small engine seems like the perfect compromise. Economical when cruising, powerful when pushed. But the public is skeptical. Americans associate performance with a sound, a deep V8 rumble. Not the high-pitched whistle of a turbo spooling. Not the sudden surge of boost. Even journalists don't fully understand the technology yet. Some praise it as the future. Others write it off as unreliable, fragile, or simply too European. The mixed messaging affects buyers. They don't know what to expect. And for many, anything unfamiliar feels risky. The automakers face another problem: quality control. Early turbo hardware is sensitive to oil quality, heat cycles, and detonation. One bad tank of low-grade fuel can upset the whole system. And in an America still adjusting to emissions regulations and rapidly changing industry standards, consistency is difficult. But despite all that pressure, engineers keep experimenting. They believe turbocharging isn't just a gimmick, it's a bridge to a new era. Inside GM, Buick is the first to truly commit. They look at a simple V6 and imagine a renaissance. The idea seems almost stubborn. Take a motor built for economy, attach a turbo, and turn it into something capable of performance. At first, the concept sounds unrealistic. But they know something others don't. The 3.8-liter block is strong, simple, and forgiving. With the right fuel system and the right timing control, it can become so much more. Ford sees a different opportunity. Instead of salvaging old engines, they build an entire division, SVO, Special Vehicle Operations, dedicated to rethinking American performance. They want cars that handle, cars that brake, cars that behave like European machines but still feel American. Chrysler, meanwhile, looks for speed in unexpected places. Compact cars, front-wheel drive, lightweight designs backed by Carroll Shelby's tuning experience. They know buyers underestimate these cars, and they see that as an advantage. There is room to surprise people. Pontiac experiments too, modifying its beloved Trans Am with a turbocharged V8 that promises incredible numbers if engineers can control the heat. They battle cooling issues, packaging limits, and inconsistent turbo behavior, but they keep trying because they want the Trans Am to survive this new age. The cultural landscape begins shifting again. Drivers want more power. They want technology, at least some do. The younger generation is curious. The older generation is hesitant but watching. Enthusiasts are desperate for something to believe in again. American cars are evolving, not replacing the past, but adapting around it. Turbocharging becomes the symbol of that adaptation, the bridge between old muscle and a future still taking shape. This is the world Section 2 leaves behind, a country searching for identity, an industry balancing pressure with possibility, a new technology ready to take its shot, if the public will give it a chance. By the start of the 1980s, American performance feels like it's running out of time. Engines are smaller, emissions equipment is more restrictive, and drivers want something that doesn't exist yet. A car that can be efficient and exciting. Inside engineering buildings across Detroit, teams begin working on something that still feels experimental. Turbocharging isn't new, but making it reliable, predictable, and truly American. That's the challenge. And this is where the story becomes human, not just mechanical. Buick, the unexpected revolution. Buick is not supposed to be the performance hero of the 1980s. That role, traditionally, belongs to Chevrolet or Pontiac. But Buick engineers see something others overlook. The old 3.8-liter V6 has potential. Not glamorous, not loud, not romantic, but strong. The early experiments are rough. Engines detonate under boost. Temperatures climb faster than calculations suggest. Turbine bearings wear quicker than expected. Engineers look at cracked pistons and scorched valves and wonder if turbocharging is really worth the trouble. But the numbers keep improving. Each time they refine timing curves, adjust wastegate control, or tweak fuel delivery, the engine starts behaving more like something alive, something eager. A young calibration engineer, unnamed in most official histories, spends long nights logging knock data, trying to understand why the engine sometimes pings under the same load it handled flawlessly the day before. He eventually isolates the issue: temperature spikes after heat soak. His fix? A smarter spark retard algorithm tied to coolant temperature readings. It works. Suddenly, the 3.8 V6 becomes manageable, predictable, promising. Buick's small gamble becomes a department-wide mission. The Turbo V6 begins gaining respect inside GM's walls, and by 1984 to 1986, these engines evolve into monsters, the ones that will power the Regal T-Type, Grand National, and eventually the GNX. But in the early development phase, no one knows that yet. All they know is that the technology is finally starting to say, yes, this can work. Ford SVO. Precision over tradition. Ford sees turbocharging as more than an engine upgrade. They see it as a cultural shift. The Mustang has survived the difficult 1970s, but it's losing the identity that once made it special. A new direction is needed. So Ford creates SVO, Special Vehicle Operations, a full division dedicated to engineering a version of the Mustang that doesn't rely on V8 brute force. They want better handling, better aerodynamics, better braking, and a modern turbocharged engine to tie it all together. This isn't just a Mustang with a new motor, it's a Mustang with new priorities. Wind tunnel models show the car needs a cleaner nose. Brake testing proves four-wheel discs are mandatory. Engineers work with Coney shocks to set up a suspension that feels European, quick, sharp, communicative. But the heart of the SVO is the 2.3-liter turbo four-cylinder, and it's both brilliant and frustrating. Boost lag is unpredictable. Detonation sometimes appears despite conservative spark timing. Cold starts show rough mixtures, and owners accustomed to instant V8 torque may find the SVO's power delivery unusual. But the engineering is ahead of its time. Intercooling becomes standard. Boost pressure is precisely managed. The engine responds well to tuning improvements. Inside Ford's engineering labs, one senior member famously remarks, "This car drives smarter than the driver." But SVO engineers know something else too. The GT still exists. Cheaper, bigger engine, easier to sell. It becomes an internal conflict: technology versus tradition. Chrysler and Shelby boost in unexpected places. No one expects Chrysler, a company facing financial pressure, to become a turbo pioneer. And yet, that's exactly what happens. The partnership with Carroll Shelby creates a series of compact, front-wheel drive performance cars that feel totally different from anything else coming out of Detroit. Lighter, more agile, turbocharged. Shelby looks at these cars the way an artist looks at a blank canvas. He takes the K platform, practical, affordable, somewhat boring, and turns it into something quick enough to surprise V8 owners at stoplights. The Turbo 1 and Turbo 2 engines evolve quickly. Reinforced blocks, improved cooling passages, stronger turbo housings. Chrysler's engineering teams, though limited by budget, innovate creatively, using parts that are inexpensive but thoughtfully adapted. A test driver later recalls the first time he felt full boost in a Shelby GLHT. It felt wrong that a small car could move like that. But Chrysler's biggest achievement is psychological. They prove that performance doesn't need to be expensive, heavy, or traditional. Pontiac, heat, hope, and the Turbo Trans Am. Pontiac enters the turbo world with ambition, a turbocharged V8 in the late 1970s and early 1980s. A powerful idea, but incredibly difficult to execute. The 4.9-liter turbo V8 promises strong numbers, but the engineering battle becomes a marathon. Heat is the enemy. Packaging is tight. Turbo placement creates hot spots throughout the engine bay. Carburetor sensitivity complicates fuel delivery at altitude and temperature changes. Pontiac's engineers feel both inspired and defeated, sometimes on the same day. They fight detonation with creative timing curves. They adjust jetting. They experiment with heat shielding. Every improvement helps, but solving every issue is almost impossible with the technology of the time. Still, they push the concept into production for the Pace Car program, proving turbocharging can work even in a large displacement application. These early failures become lessons that later manufacturers use when designing turbocharged engines that don't overheat, that don't detonate, and that do perform consistently. Human stories, the people behind the boost. This era isn't shaped by brands, it's shaped by people. Individuals who believe in turbocharging even when the market doesn't. A Buick engineer who stays overnight running spark maps on a primitive test computer. A Ford SVO team member who argues that the Mustang needs to evolve or die. A Chrysler mechanic who figures out a better routing for turbo coolant lines after watching cars overheat during desert testing. A Pontiac engineer who keeps pushing despite corporate cuts because he wants the Trans Am to stay relevant. None of these people know they are contributing to the future of American performance. They're simply trying to solve today's problems. But looking back, you can feel their impact. A turning point approaches. By 1984 to 1985, the development programs across Buick, Ford, Chrysler, and Pontiac start producing real results. Engines get stronger. Boost becomes more manageable. Technology catches up with ambition. These companies begin releasing turbo-powered cars that feel faster, sharper, and more confident than anyone expected. The stage is set. The technology works. The engineers have done their part. All that remains is one question. Will America accept a new kind of performance? By the mid-1980s, the experiments of Buick, Ford, Chrysler, and Pontiac have all reached the same doorway, the point where turbocharging stops being an idea and becomes a real mechanical system that must work every single day. This is the section where the story leaves emotions and enters engineering, because turbocharging is simple to describe, but difficult to master. At its core, the idea is straightforward. Force more air into an engine than it can naturally inhale. More air means more oxygen. More oxygen allows more fuel. More fuel means more power. But achieving that in 1980s America is harder than it sounds. Much harder. Most domestic engines are designed for low compression, low temperature operation, and simple carburation. Turbocharging pushes them in the opposite direction. High pressure, high heat, and tight tolerances. And the tech of the time is barely ready for that level of precision. How a turbo works and where it fights back. A turbocharger is spun by exhaust gas. That gas hits a turbine wheel, which turns a compressor wheel, which forces air into the intake. But the exhaust gas is hot, extremely hot, up to 1,600 degrees Fahrenheit in some cases. This creates several challenges. Metal fatigue, bearing wear, detonation in the cylinders, lubrication breakdown, heat soak after shutdown. The engineers of the 1980s spend countless hours addressing these issues with whatever tools exist at the time, often imperfect tools. Buick's Turbo V6 uses early computer-controlled spark timing and a knock sensor to prevent detonation. Ford relies on intercooling to cool the compressed air. Chrysler uses stronger block casting on Turbo 2 engines to handle higher pressures. Pontiac experiments with heat shielding to keep the Turbo V8 alive under high load. Each solution is a patch on top of an older generation engine. That's what makes the engineering impressive. Air, fuel, spark, the balancing act. Turbocharging stresses all three major engine fundamentals. 1. Airflow. The turbo forces in more air than natural vacuum can pull, but this increases heat dramatically, so engineers add intercoolers, revised intake routing, thicker gaskets, reinforced hoses. Without these upgrades, boost pressure simply tears old components apart. 2. Fuel delivery. Early carburetors struggle with boost. Fuel mixture becomes unpredictable. So engineers shift toward throttle body injection, multi-port fuel injection, revised injector pulse strategies. This is the first era where computers start taking real control of fuel delivery. 3. Spark control. Turbocharging increases cylinder pressure, so ignition timing must be perfect. Too advanced equals detonation. Too retarded equals sluggish performance. Buick's ESC, electronic spark control, becomes one of the most important inventions of the decade. Ford's SVO uses a computer-controlled boost curve. Chrysler develops clever timing tables that change with RPM and manifold pressure. For the first time in American engineering, the engine becomes something that must be monitored in milliseconds, not seconds. Boost pressure, the invisible engine. One of the most interesting things about turbo engines is that their power isn't just horsepower, it's pressure. A turbo motor can feel calm and then suddenly alive, depending on boost behavior. Engineers call this boost response. Drivers call it lag. In the 1980s, lag is a major challenge. Small turbos spool fast but run hot. Large turbos stay cool but spool slowly. This becomes a delicate game. Buick chooses medium-sized turbos to balance response and power. Ford prioritizes high RPM response for SVO's road course goals. Chrysler picks smaller turbos for their lightweight compacts. Pontiac leans heavier, prioritizing steady boost over response. None of these choices are wrong. They simply reflect different philosophies. Cooling, the silent enemy. Heat is the real villain in this era. Everything about turbocharging multiplies temperature. Compressing air running rich mixtures, high exhaust flow, metal stress under hood packaging. Pontiac especially faces this problem. Their Turbo V8 struggles because the Trans Am's engine bay is tight and airflow is limited. Buick fights heat with revised coolant channels and improved oil return passages. Ford cools air with an intercooler, one of the most important add-ons of the decade. Chrysler revises turbo bearing housings to improve oil flow. The engineers slowly gain control over heat, but it's a daily battle. Materials, strength in the details. Turbocharging forces engineers to rethink material choices. Stronger pistons, reinforced connecting rods, sodium-filled valves, higher temperature-resistant turbine housings, better oil pumps, improved gasket materials. These may seem like small changes today, but in the early 1980s, they are groundbreaking. Buick's 3.8 block becomes legendary, partly because of its unexpectedly strong metallurgy. Chrysler's Turbo 2 components become favorites among tuners for their durability. Ford SVO's intercooling becomes a blueprint for future American performance engines. Comparing power, turbo versus V8. The numbers tell the story better than anything. Buick GNX, 276 horsepower, but realistically much higher. Ford SVO, 175 to 205 horsepower. Chrysler GLHT, approximately 146 horsepower in a very light chassis. Pontiac Turbo 4.9, modest horsepower, but strong torque. Compare this to typical early 1980s American V8s making 120 to 150 horsepower, often with poor efficiency. Turbo engines become the unexpected heroes of their time. They're not perfect, but they're proof that small displacement and intelligent engineering can outperform raw size when the environment demands it. Electronics, the invisible revolution. The most important advancement of the 1980s turbo era isn't the turbo itself, it's the electronics that make it usable. You now see digital engine control, knock sensing, boost control logic, ignition maps, early onboard diagnostics, closed-loop fuel strategies. These systems allow turbocharging to exist at all. Without them, overheating, detonation, and fuel inconsistency would destroy engines in days. Turbocharging forces American automakers to think smarter, not bigger. A system on the edge of the future. By the end of the technical phase, the engineers have done something remarkable. They've created turbo systems that work, repeatably, reliably, and in some cases, brilliantly. Now the question is no longer whether the technology functions. It does. It's ready. The question shifts to something bigger. Will America accept this new form of performance, or turn back to the V8 forever? By the mid-1980s, the engineering behind turbocharged American cars is finally strong, reliable enough, powerful enough, ready enough. But technology alone never decides the future. Culture does. And the culture of American performance is complicated, built on decades of habits, sounds, memories, and pride. Turbocharging doesn't enter this world quietly. It arrives with a sharp whistle instead of a deep rumble. For many drivers, that sound is unfamiliar, alien even, because for generations, performance in the United States has meant one thing: displacement, power from size, power you can hear and feel at idle, the kind of engine that communicates through vibrations before you even touch the throttle. Turbocharging, by comparison, is subtle. The boost comes later, the sound comes differently. Power arrives in a rush instead of a wave. And that creates a disconnect for some drivers. A culture caught between past and future. The 1980s American car buyer is standing at a crossroads. They want the speed the past promised, but the past is shrinking under emissions rules and fuel standards. They want new technology, but not if it replaces the familiar rumble they grew up with. This tension shows up in dealerships across the country. Salespeople notice customers loving the idea of efficiency and turbo power, but hesitating at the test drive. Some walk away because the engine note doesn't match their expectations. Others because the boost lag feels strange. And this isn't the buyer's fault. They're experiencing something different in a landscape that hasn't taught them how to read this new kind of performance. For example, the Ford Mustang SVO is praised in magazines, but buyers still choose the cheaper V8 GT. The Buick Grand National is fast, shockingly fast, but some traditional buyers still prefer the look and feel of large displacement. Chrysler's Shelby compacts surprise young drivers, but older buyers remain skeptical of small turbo engines replacing big engines. Turbocharging enters a culture still learning how to trust something that doesn't sound like the past. The magazine effect. Automotive magazines shape public opinion heavily during this era, and their reactions are mixed. Some journalists love the innovation, the engineering courage, the fresh direction. They write articles calling turbocharging the future of American performance and praise its efficiency. Others call it a temporary fix, a technology that can't replace displacement, a European trend that doesn't align with American values. This inconsistent messaging creates cultural turbulence. Buyers don't know who to believe. A person reading one magazine might think the Mustang SVO is the next big step, but another article might frame it as a niche experiment. Enthusiasts want identity and clarity. Turbocharging gives them speed, but doesn't give them the emotional script they grew up reciting. Price versus tradition. Many turbo cars cost more than their traditional counterparts. More engineering means more R&D cost, more sensors, more control units, more special hardware. The Mustang SVO is a perfect example, technologically better than the GT, but priced above it. Enthusiasts look at the price tag and think, Why pay more for a four-cylinder when the V8 is cheaper? Buick's GNX is brilliant, but expensive. Chrysler's Shelby models offer great performance, but their image, small front-wheel drive, doesn't fit the American performance identity of the time. And Pontiac's turbo experiments appear ambitious, but inconsistent reliability scares traditional buyers. The market isn't rejecting the engineering, it's rejecting the unfamiliarity. Enthusiast subcultures form. Still, something interesting happens during the mid-1980s. Small but passionate communities start forming around these turbo cars. Buick Grand National owners trade tuning tricks. SVO fans run track events and corner carving meets. Chrysler/Shelby fans build scrappy, clever performance clubs. Pontiac turbo fans celebrate the uniqueness of the pace car editions. These groups don't fully change mainstream culture, but they keep the flame alive. They create early turbo lore, stories about surprising bigger cars, stories about tuning potential, stories about what these engines could become with the right support. These subcultures become the roots of something the industry won't notice until decades later: turbocharged performance becoming the American norm. Why turbocharging didn't take over in the 1980s. The engineering was ready, the cars performed. So why didn't turbocharging become the dominant American performance path back then? 4 cultural reasons explain it clearly. 1. Drivers weren't ready to abandon V8 identity. Sound, tradition, pride, all deeply rooted. 2. Magazine messaging was inconsistent. One article praised turbos, another dismissed them. 3. Early hardware had real-world quirks. Heat issues, inconsistent fuel quality, turbo lag. 4. Pricing and perception clashed. Buyers didn't want to pay more for smaller engines. These aren't engineering failures, they're cultural timing issues. Turbocharging arrived slightly too early for the American mindset of the 1980s, but it planted seeds the culture would return to later, once the technology matured and once the V8 began facing new pressure in the 2000s and beyond. A quiet influence that grows over time. Even if turbo cars didn't dominate the 1980s, they changed direction, quietly, steadily, and permanently. They taught engineers how to manage heat. They taught tuning teams how to balance boost and timing. They introduced electronic engine control as a necessity. They helped drivers understand a new kind of acceleration, and they showed that small engines could be serious. Their cultural impact wasn't loud. It was gradual, like pressure building in a system not yet ready to open fully. This influence will matter deeply in the next section, the legacy, where turbocharging becomes not just a niche experiment, but the backbone of modern American performance. The 1980s turbo era ends quietly. No headlines, no dramatic final chapter, just a slow fade as American automakers return their attention to newer V8s in the 1990s. But something important happens underneath that silence, a shift that doesn't become obvious until decades later. All the struggles, experiments, failures, and breakthroughs of the 1980s form the foundation of the engines America relies on today. Turbocharging didn't win in the moment, but it won in the long run. The return of boost, this time for everyone. By the early 2000s, fuel economy laws tighten again, performance expectations rise again, and the V8 faces pressures that feel familiar, the same cycle the industry saw in the 1970s. But this time, the engineers are ready. They open old notebooks, old dynamometer logs, old turbo reliability reports, and they realize something. All the answers are already there. The test failures Buick solved in 1983, the spark tables Ford perfected in 1985, the cooling innovations Chrysler invented on a shoestring budget, the heat shield lessons Pontiac learned through frustration. These become the blueprint for modern turbo engines. The technology that once struggled in shadows now becomes mainstream. Modern examples, built on old lessons. You can see the legacy everywhere. Ford EcoBoost engines, Mustang, F-150, turbo V6s replacing V8s in trucks and SUVs, compact performance cars using small displacement with high boost, high-end sports cars relying on twin-turbo architectures, even American supercars turning to forced induction. All of it traces back to the engineering work done in the 1980s. For example, The NOx sensors that Buick helped pioneer are now standard on nearly every modern engine. The intercooling strategies the SVO team refined are now applied across performance platforms worldwide. Chrysler's durability experiments inspire stronger modern turbine housings. Pontiac's struggles with packaging influence better airflow routing in modern turbo V8s. The legacy isn't just technical, it's philosophical. Turbocharging teaches American engineers that power can come from intelligence rather than displacement. Collector status and cultural redemption. Cars that were once misunderstood now rise in value. At auctions, a clean GNX is treated like a national treasure. Mustang SVOs develop a cult following. Shelby Dodges, once dismissed as econobox toys, become rare finds. Pontiac Turbo Trans Ams gain respect for their ambition, even if they were imperfect. Collectors now talk about these cars with the same tone of respect they reserve for muscle classics. The flaws become part of the charm. The limitations become proof of how far ahead these machines were trying to go. It's a quiet kind of redemption, not loud, not dramatic, but earned. A new generation that grew up with Boost. There's also a cultural shift. Today's drivers grew up in a world where turbo lag is normal, where whistling boost is part of everyday soundtracks, where power delivery doesn't have to rumble to feel real. Younger enthusiasts don't carry the old V8 versus small engine identity conflict. They grew up with video games, YouTube builds, and tuner culture, spaces where turbocharging is celebrated, not questioned. For them, the 1980s turbo era feels less like a failed experiment and more like the prologue to the world they know. The emotional legacy. Persistence over perfection. What makes the 1980s turbo story special isn't just the engineering, it's the persistence. The belief that American performance could evolve when it felt like everything was collapsing. Buick's long nights, Ford's bold division experiment, Chrysler's creativity under pressure, Pontiac's stubborn commitment to a difficult idea. These aren't stories of perfect success. They're stories of people trying to move forward when the automotive world around them felt uncertain and afraid of change. And that makes the legacy human, not just mechanical. Turbocharging today, the standard, not the exception. Modern performance cars, trucks, and even family SUVs now rely on high boost pressures, direct injection, precise timing control, intercoolers, twin-scroll turbine technology, electronically controlled wastegates. All of these systems descend directly from the pioneering work done in the 1980s. The idea that small engines could be serious performers, once controversial, is now accepted across the entire industry. Even traditional V8 brands incorporate turbos into their future plans. Turbocharging no longer needs to defend itself. It quietly became the backbone of modern American engineering. A legacy that arrived late, but arrived strong. The greatest irony is this: turbocharging was meant to save American performance in the 1980s, but its real victory happens 20 to 30 years later. It didn't win when it first appeared, but it shaped the future so completely that today's automotive world would feel unrecognizable without it. This is the legacy, not loud, not immediate, but undeniable. And it leads directly into the final question of this documentary. What did turbocharging leave behind that still powers the American automotive identity today? American performance enters the 1980s unsure of itself. Engines shrink, power fades, and the identity that once defined the country's automotive spirit feels like it's slipping away. Turbocharging steps into that uncertainty, not as a miracle, not as a perfect solution, but as an attempt to keep the story alive. An attempt built on pressure, heat, risk, and long nights. An attempt built by engineers who believed the future needed more than nostalgia. When we look back at that era today, it's easy to see the imperfections. Turbo lag, heat problems, confused buyers, skeptical journalists, a market not fully ready to trust the unfamiliar. But if you look deeper, the truth becomes clearer. Turbocharging didn't fail. It arrived early. It entered a culture still holding on tightly to the past, a culture that wasn't prepared to rewrite its definition of performance. And yet, the technology stayed. It survived long enough for time to catch up. The lessons learned in those garages, test cells, suburban driveways, and industrial backlots became the foundation for nearly every modern American engine. That's the legacy: quiet, steady, impossible to ignore. The Buick engineers mapping NOx sensors by hand, the Ford SVO team testing aerodynamics and intercooling, the Chrysler techs reinforcing tiny turbo housings, the Pontiac crews fighting heat one shield at a time. They were all building something they would never fully get to see, but we see it now. Every EcoBoost Mustang, every turbo truck, every modern performance car shaped by airflow, pressure, and precision. The 1980s turbo era didn't save American performance in its own decade, but it saved the future. It carried the ideas forward until the industry finally needed them again. And that brings the story full circle. Turbocharging didn't get its moment then, because its moment was waiting here, in our time, in our cars, in the world those early engineers helped create. This is the legacy of the 1980s turbo cars, a forgotten fight that shaped the future without ever getting the spotlight it deserved.